This is our video for test case 1, in which we are tasked with logging into the client and producing a successful login, in which we have to set a breakpoint quote login button event handler, step through the execution all the way until the client GUI shows the list of contacts, if any, waiting to start a chat or be part of a chat. In this situation, we can see that the server is already online, and currently Caleb is the only user online. It's verified here. We can also see that the breakpoint was already set in the, my apologies, in the userview.cs login button underscore click. To log in to the user account named Nathan, we give it the password of swordfish, and then click login, which will trigger the breakpoint. From here, we can see that it does in fact trigger the login button breakpoint, and then grabs the username from the username UX username textbox.text and the string password of UX password textbox.text. Then it checks to see if the strings for both username and password are either null or contain white space, and if they do, then it bypasses it and shows a message box.show to the user that the username and password must be entered. From there, on a successful login, it validates the login through a delegate, which ties into a method called sendLogin in the client controller. When sendLogin is passed, it is passed both a username and password, obviously the username and password that is given in the UX text box. From here, we connect to the server for a login, and then proceed to send it credentials of the login, as well as right here, we can see that we are piping a login parameter to the server to let the server know that, hey, this is a login message. From here, we tell the current WebSocket to send the credentials to the server, and then apply the current name of the user to the username passed through sendLogin.
Due to the functionality of our code using delegates to navigate many different form methods, we had intended to have a Boolean type of return on most of our send methods to verify that the send was successful, and we would use that as a platform from which to send message boxes, but we did not have the ability to get that verification added. So unfortunately, we have to just return true. This is effectively a void method.
From here, we can see that the code does go in fact continue on through the login button click. And then we can see that the update is called because the contacts are being updated, in which it invokes two new actions. One sets the UX user list box.data source equal to null first to verify that it is in fact empty. And then we set the data source again to a new list of user proxies of the current contacts that were passed from the server. On producing these actions, we can see that it proceeds to go through with no problem, and upon hitting continue, we can see that it does in fact populate the user contact list. Welcome to test case 2. Start conversation with a person in my contact list that is online. Set a breakpoint in the event handler for the chat button. Step through the execution all the way until the selected user to chat with pops up to the chat window.
All right. As you can see, we have two user views. Both clients have a stop point in the same spot, so we can pick either one. I will log in Nathan, same as we did, and then I will log in Jorge with his password. Log them in. They're now both shown as online, Jorge here and Nathan here. I will now click the chat button on Jorge's side, which will lead to this. So I will then turn that to full screen. With the click of that button, we grab the temporary variable from the list box showing the contacts. Now we know the contacts are a group of user proxies, but we still have to check just for safety reasons in case anything comes along. So we check if it's not null, and then we also check if we can cast it as a proxy, in which case we then make another contact proxy variable that is cast as that is the original temporary variable cast as a user proxy. From this point, we do another couple checks to see if that contact variable is in fact online, which we picked Nathan from Jorge, who was shown as online, so it will in fact fall into that. But if it didn't, it would take the it would take some of the information from other aspects and state a message box error to prompt the user to pick a correct user. So passing this first if statement, we then fall into the open delegate where we pass that contact information. From that point, we go to the client controller, which has a method called openRoom. openRoom establishes a connection with the WebSocket, then adds the member, the name and a Boolean value of true to represent the client user that is on this port of the client, and then in addition add to the chat members field on this that resembles every member in a chat room with that client. So it then adds, sorry about these overrides, it just likes to fall into them. We add to that same chat members field the contact that we want to open our chat with, and I will step over where we have once we have those members added, we then use the JSON convert serialize object function from Newtonsoft JSON parsing, which turns that list of chat members into a string. And once that is completed, we tack that on to a open flag, which will be handled by a method in the user controller of our server, which I will show now. My bad, I did not have it pulled up. My bad. So I have a stop point there, at which point we go back to our original client and continue stepping. We call that send method, and then we return true. As established earlier, we have a problem with those methods of returning true. There is intended to be extra functionality in this UX chat button click, but we could not quite get around to that. And with that, it'll end. We'll go back to our server call, which processes that flag from a message received. It would appear that our WebSocket server timed out. That is something we've been having troubles with. I can restart it and show it off again. Okay. But you can see that there are a number of pieces here. We take a chunk from the string, we split it based upon those pipe characters, and we have a number of different flags that handle what to do. In the case of open, it is down a ways. It's right here. It would have gone through here and returned the variables that we want. So I will quickly restart it and just run it to show that it does indeed open. You just have to be a bit quick with it. So as discussed earlier, we'll start our server. We have a couple automatic entries for login purposes. So that automatically starts our server. We will then start another client. We'll use the automatic Nathan code, which logs Nathan in. And then we will create a new client. This one will have to be changed to Jorge, along with his password. Log in. It hits that on message from the server flag that I showed earlier. And we have our user view of Jorge. I will click chat, hits that method, and we have a couple of chat windows. They do not quite have all the labeling that we would like, but these are in fact chat windows for an individual client. We can show that by closing one of these clients, which will close both a chat window and a instance of a viewer major. There you go.
Test case 3. Delete. Delete one of my contacts. A contact that is on/offline. It should not matter. Set a breakpoint in the event handler for the delete button. Step through the execution all the way until all the users that had the deleted client in their contact list removed from their deleted list, or removed from their list.
Unfortunately, due to the unforeseen problem we had with the WebSocket timeout, we were not able to get this feature implemented. However, we did have an extensive plan for all the functionality of this program. We do have a roadmap that would allow us to complete this with fairly minimal changes and very little legwork. So, as you can see, we have a button here called Fake Delete. I have added this for the purposes of demonstration. It is not in our final commit. From this Fake Delete button, we would have called a Fake Delete click, here just titled button one click, and as following with all of our other types of model view controller related data separation, this would have handled information passing and simple parsing, stuff like making sure that the selected item was actually an item and a user, stuff for simply data safety. And then from that point, it would have called a delete delegate if that given data was in fact valid. So from that delete delegate, it would have gone to a call in our client controller class, which has a number of classes that all send data to our server. You can see a number of them down here. I have set up our fake delete, and it would have followed a very similar pattern to all of these. So in most of our classes, in all of our sending classes, we had to open WebSocket.connect, even though we know that you only need one. That was something that we were trying to fix, and we did not have time to address in our last fix. So this likely would not have had that WS Connect. Otherwise, the pattern would be very similar. You can see in login that you have a string credentials that then gets packaged into a dense piece of information. You have a login string flag, and I'll show the purposes of that later, as well as a username from the parameters and the password from the parameters. That is then sent to the server, and the name of this class is set to username. That's a bit special, and then we have the aforementioned return true from the last two trials. So the pattern would have been very similar here. In fact, I've even set up an example string. We would have called this delete as a flag, and then we would have packaged this client into a serialized string information that would then be read by the user controller in the server, as well as the serialized version of the contact, which would also then be fed to the server. So once send has been fed, we all go into a on message. From there, the event sending that has data, which we pull, and we then delimit based on the pipe character, as you can see in these variety of strings here. Once that is delimited into a string array called chunks, we call a variety of different groups that can check and act as methods. This realistically would have been broken into helper methods had we not had the issues with timeouts. But again, unfortunately, we could not deal with that in time for the turn-in of this. So this would have had a delete flag, which would have been pulled from the very first index. And then from there, we would have called delete and remove, which all would have been methods handled in our user database class, which is a static class that acts as a floating database accessible by the two controllers that we have in our server-side features. So this user database features a hash set of users, a dictionary to track user session IDs, which is useful for sending information to clients, and then a variety of other hash sets of a class called contact, which is the base class for user and what the user proxy class in our client side directly maps to. So that is a little bit more data free and easier to parse. That we keep the users as a data set for login purposes. And then we have the active list to show who is active, as well as chatting for the purposes of not allowing a user to be in multiple chat rooms at one time. This is initiated from a Java file that we have attached called file name. That is fed through a main class. We have a little experiment here that did not get deleted, and a variety of methods. So we have a method called add user to user database that would have been used to add a new user to the user database. Can chat, which is used to check if a user is in fact eligible to be added to a chat room class, which handles the chatting aspect of our program. So it would have been similar to this. It would have checked if that user is in the contacts of a user in the users list or hash set, my bad. And if you can remove that, then you would. Otherwise, you would report back some type of error. And from that point, it would have been passed back into the client controller class via its own message handled class, which has a attached method called direct services, and it is set up in a very identical way. Actually, it uses that message, which it then delimits into a pipe and handles those by acting as a bunch of items that should be held in helper methods for legibility, but for the purposes of speed, we left in this one method. That would have been the roadmap to our delete method. Thank you for watching.